Hello friends, in continuation with our chapter Introduction to MongoDB, today we'll study this aggregate function. Now first we'll see what is aggregation, then we'll see aggregate function, and then we'll go with this example. We'll see this example. Aggregation in MongoDB is nothing but an operation used to process the data that returns computed results. Aggregation in MongoDB is nothing but an operation used to process the data that returns computed result. Now let us see what is aggregate function. Aggregate function groups the records in collection and can be used to provide total number, average, minimum, maximum, etc. out of groups selected. See again, I will repeat. Aggregate function groups the records in a collection and can be used to provide that number, average, minimum, maximum, etc. out of groups selected. Now let us see the example. See our objective. Consider the collection of customers as given below. It has 4 documents. Now we have one collection named customers and it has 4 documents, and our task, see, we would like to filter out those documents where account type has value other than S. After the filter, we should be left with 3 documents where the account type S. It is then required to group the documents on the basis of customer ID and sum of the account balance for each unique customer ID. Let us say our aim is to find or sort the documents with account type S, and then we will filter and we will have account balance. The value it must be greater than 1200. This is similar to the output received with the group by clause in the RDBMS. See, once the groups have been formed, yes, then what is expected? Crude ID, customer ID C123 and customer ID C111. Filter and display the group where the account total balance column has the value greater than 1200. Now let us see this. We have 4 documents: customer ID C123, account balance 500, account type S. Second one is customer ID C123, account balance 900, account type is S. Now next is customer ID C111, account balance is 1200 and account type is S. And last one is customer ID C123, account balance is 1500 and account type is C. Here our requirement is we have to find the account type S. So it will match and it will find customer ID 123, account balance 500, account type S. Second one C123, account balance 900, account type S, and customer ID C111, account balance 1200, account type S. It means only documents are taken out whose account type is S. Then it will group. Then it merge the values account customer ID. See this C123 and total account balance is 1400 and second is C111, account balance is 1200. Simply here we filtered and found the customer IDs whose account type is S, and then at the end we found is 2 documents. One is total account balance is 1400 and second is total account balance is 1200. Now let us see how it happens. First let us start by creating the collection. Now first we will create the collection, and for that we will use the syntax db.customers.insert. As previously we went through this how to insert, then also we will revise. See this customer ID C123 account. Let us start off creating the collection customers with the above displayed 4 documents. Now we will add these 4 documents, that is customer ID C123, account balance 500, account type S. Second, customer ID C123, account balance 900, account type S. Then next document, customer ID C111, account balance 1200, account type S. And customer ID C123, account balance 1500, account type. And for that, this db.customers.insert will insert these values. Now this, with this db.customers.insert will add these values to the collection named as a customers. Now next step is to check whether these documents are added to this customer collection, and to check we'll execute command db.customers.find.pretty. It means with this command we can verify whether these all elements, all the documents are added or inserted to the collection customers. See, we can see db.customers.find.pretty. We executed and we found these 4 documents available. It means it is clear that we have 4 documents in this collection customers. Now next is to group on customer ID and compute the sum of account balance. We'll use this syntax db.customers.aggregate. Here ID, customer ID, total balance, sum, account balance. Here it will be addition. See, let us see what happened. Say it added, it found aggregate. We'll execute this db customer.aggregate and it will find these values. In order to first filter account type S and then group it onto the customer ID and then compute the sum of account balance, we'll use this syntax db.customers.aggregate. Yes, it will match with account type S and then group ID, customer ID, total balance, sum, account balances. Here it will group with account type S and then it will compute the total account balance with this syntax. In order to first filter account type S and then group it on customer ID and then compute the account balance and then filter those accounts wherein the total account balance is greater than 1200, and we will use this syntax db.customers.aggregate. It will match with at account type S, then it will group customer ID, total account balance, and it will sum account balances, and it will match total account balance is greater than 1200. Now to group the customer ID and compute the average of the account balance for each group, we will execute this command db.customers.aggregate group ID, customer ID, total account balance, average account balance. Second one is to group customer ID and determine the maximum account balance for each group. db.customers.aggregate, it will group customer ID and then total account balance is the maximum account balance. It will find the maximum account balance. And next one is to group customer ID and determine the minimum account balance for each group. db.customer.aggregate, here it will group according to customer ID and total balance. It will check and find the minimum account balance with this syntax. Now let us see, we will go for the next MapReduce function. MapReduce is a data processing paradigm for condensing large volume of data into the useful aggregate result. So this MapReduce, what is MapReduce? MapReduce is a data processing paradigm for condensing large volume of data into useful aggregate results. And in MongoDB uses MapReduce command for MapReduce operation. Here in MongoDB uses MapReduce command for MapReduce operation. Let us take example. Here we will take example. Here our objective is consider the collection customer There are 4 documents. Run a query to filter out those documents where key account type has value other than S, and then each unique customer ID prepare list of account values. This is our objective. For example, customer ID C123 and account balances are 500, 900. This task will be assigned to the mapper function. For example, this customer ID C123, the account balance are 500, 900. This task will be given to the mapper function. The output from the mapper function serves as the input to the reducer function. The reducer function then aggregate the account balance for each customer ID. For example, customer ID C123, the value is 1400. We can understand simply here the function of mapper function is to add these two values 500 and 900. It calculated and found the value 1400. See this. Here the mapper function customer ID 123 and account balance 500 900. This task will assigned to the mapper function. The output from the mapper function serves as the input to the reduce function, and reduce function then aggregate the account balance custom. For example, customer ID C123 value will be 1400. So here we have these 4 documents with customer ID C123, account balance 500, second 123, 900, customer ID C123, account balance 1200, and last one customer ID C123, account balance 1500, account type C. Now here it sorted this mapper function sorted. See this, it sorted with account type S. It found all these 3 documents with account type S. The C123 account balance 500, customer ID C123 account balance 900, and customer ID C111 account balance is 1200. Here common thing is account type. So aggregate, and then it will find specific C123 and C111 is, and it will aggregate, it will add. There is the addition of 500 900, it will become 1400. Is at the end will find 1400, and there is nothing to do with this second entry, that is C111 1200. It will be remain as it is. At the end will find this value. The result of this map will be given to the reducer, and it will find the final value 1400 and second value 1200. Now we have the syntax for this MapReduce: db.customers.mapreduce. Here function emit this dot customer ID, this dot account balance. Second, reduce function key values return arrays dot sum values, and query account type as, and output will be customer totals. Now map function, where map is equal function emit this dot customer ID, this dot account balance, and reducer function where reduce is equal to map, where reduce is equal to function key value and return array dot sum values. To execute this query, we'll execute this query with this syntax: db.customers map reduce map comma reduce output customer total query account type S. The output will be like this. Output will be C111 value 1200 and C123 value 1400. Now next we'll go for this JavaScript programming. Then we'll go for this JavaScript programming. Now how this JavaScript programming deals with this MongoDB, let us see. Here our objective is to compute the factorial of a given positive number. The user is required to create a function by name factorial and insert it into the system.js collection. First, before we proceed, a quick check what is contained in the system.js. Yes, first it will execute db.system.js dot find. If we execute db.system.js dot find, we'll check whether something is in this system.js. He will find nothing in this. Will find nothing in system.js as we executed db system.js dot find. Now we'll insert. Our task is to insert a function factorial. Our aim is to find a factorial. So the action will be taken as like this. Act is we have to act accordingly. db.system.js.insert id factorial. It means we are adding factorial code in system.js. Value is equal to function n. If n equal to 1, return 1, else return n into factorial n minus 1. This will be the code inserted. JavaScript is inserted in system.js. Now we will confirm now whether this factorial function is available in java.collection, java system.js collection. Now to confirm, we have to execute db.system.js again find, and as soon as we execute db.system.js.find, we can see this code, this function is available, and as soon as we find the function is available, then we can execute and can find the factorial. And to find the factorial, the syntax is db.eval. Now suppose I want to find the factorial of 3, I will write db.eval factorial 3. If I want to find the factorial of 5, I will write db.eval factorial 5. And if I want to find the factorial of 1, db.eval factorial 1. In this way we can calculate the factorials. In this way we deal with the MongoDB with the JavaScript programming. Now next is cursors in MongoDB. Now cursors in MongoDB, let us see what is cursor. The cursor is a MongoDB collection of the documents which is written upon the find method execution. See, the cursor is a MongoDB collection. It's a MongoDB collection of the documents which is written upon the find method execution. It returns upon the find method execution. As soon as find method is executed, it returns. Now let us see with the example. Cursor in MongoDB. Our objective is to create a collection by name alphabets and insert document in it containing two fields, id and alphabets. First, the value stored in alphabet field should be a, b, c, d, etc. with one value stored per document. Here our aim is to create one collection alphabet and in it containing two fields, one will be id and second will be alphabet, and in one document there will be one alphabet. In first document a, second document b, third document c, like this. There should be 26 documents in all. We need to use cursor to iterate through the alphabets collection. The alphabet is the name of the collection and alphabet is the name of the field. See this, we have to capital alphabets is the name of collection and alphabet, small alphabet, is the name of the field. Now we will create. Now our aim is to create collection with alphabet with its 26 documents. Here as the alphabets are 26, we will create collection with alphabet. Now we'll use db.alphabet.insert. We'll use this db.alphabet.insert to insert the documents in collection alphabets. See, first db.alphabet.insert id1 alphabet a. It means first document's ID is 1, alphabet is A. Second, db dot alphabet dot insert id to and alphabet B. See, in this way it will repeat it up to Z. See, like this, al db dot alphabet dot insert id 15 alphabet O, db dot alphabet insert id 16 alphabet P, and it will end at db dot alphabet dot insert id 26 and alphabet Z. Now in this way, this is a screenshot. This is the screenshot for this in db.alphabet.insert command. Now we have to confirm. Our aim is to confirm whether all the 26 documents are available in alphabet collection. Now for that we have to execute db.alphabets.find here to find the documents in collection alphabet. Will execute db.alphabets.find, so it will find the values. Yes, it will show display the values id1 alphabet A, like this. It will run up to Z. A quick word on how db.collectionFind method works. This is a primary method for read operation. In other words, it allows one to fetch document from the collection. To be able to access document, one needs to iterate the cursor. However, in the MongoDB shell, it returns cursor is not assigned to variable using var keyword. The cursor is automatically iterated up to 20 times to print the first 20 documents in the result. Let us see. In this example, here it will display id1 alphabet A and at the end id 20 and alphabet T, and then it will go for the next. Okay, thank you. This is the end of this chapter, introduction to MongoDB. Thank you.